ready to start testing.
Excellent. But before we begin, let's educate ourselves on the concept of absorbent polymers.
What is a polymer? A polymer is a long chain of repeating units. These repeating units are known as monomers. Shown here are some different monomers. The N represents the number of monomers in a specific polymer. Polymers can be formed through many methods, including condensation and addition reactions. Polyethylene, shown on the left, is by far the most commonly produced and largest by volume in the world. It is used for everyday applications in plastics like shopping bags. In the middle is polyisobutylene. Polyisobutylene has seen uses as a major component of synthetic rubber. On the right, you can see polystyrene. Polystyrene is most commonly known under the trade name styrofoam and is useful as a rigid plastic which can be formed into containers and shipping packages. A specific functionality of some polymers is their ability to absorb and retain water. After absorbing water, these polymers tend to form hydrogels if cross-linking has occurred between polymer units, or if cross-linking has not occurred, they will form a cake-like dry slush.
Video shows the addition of colored water to an absorbed polymer. In this first experiment, cross-linking occurs and a hydrogel is formed. As you can see how quickly this reaction occurs. In the second experiment, cross-linking does not occur and a dry blue slush-like substance remains. As you can see, this is a very efficient way to clean up wet spills. When salt is added to the slush, the process reverses, recreating a liquid.
Here are some examples of absorbent polymers. On the left is sodium polyacrylate, in the middle polyacrylic acid, and on the right is polyacrylamide. Sodium polyacrylate is commonly used as the premier slush powder. Polyacrylic acid is commonly used in baby diapers. Polyacrylamide sees similar functions as sodium polyacrylate and polyacrylic acid. Here you can see how polymers are able to retain water. Polymers are able to retain water because the water molecule attacks the polar functional group on the backbone of the polymer. You can see this here, shown by the pink arrow. This causes the water to be readily absorbed by the polymer, much in the same way water dissolves salts and sugars. On the left is a dry polymer, and on the right is the same polymer after introduction of water molecules. One of the most common applications of absorbent polymers is their inclusion in baby diapers. Specifically, most diapers contain polyacrylic acid.
Here we did a quick test on the absorbent capabilities of baby diapers. This was done by applying approximately 100 ml of color fluid to the baby diaper and observing its absorption and retention of fluid. A normal baby diaper has 4 to 5 grams of absorbent polymer, typically polyacrylic acid. This quantity of absorbent polymer allows it to absorb between 100 to 150 milliliter just from the polymer.
Other useful applications are as a spill powder, which can occur as a cloth or as a coarse powder. It is spread over the wet spill and swept up and disposed of. Next is a flame retardant gel. Due to the high quantity of water in gels, this provides unsatisfactory conditions for fire propagation. This is because most of the energy from the flame is absorbed in the evaporation of water. Another application is in coagulated foods like jams and jellies. Jams and jellies and other coagulated foods utilize naturally absorbent polymers found in cell walls known as polysaccharides.
As you just learned, absorbent polymers can be used in many applications, and there are many future possibilities that they could be used in as well, including even more absorbent products.
It can be used in oil spill cleanups and in agriculture by enhancing soil permeability and infiltration rates, and stopping erosion and water runoff.
They can increase plant performance in structureless soil and in areas subject to drought.
Again, thank you for watching our video and taking the time to learn about absorbent polymers.